Example number 6, evaluate the limit of h cubed minus 4h over h cubed minus 2h squared as h approaches 2. Okay, substituting 2 for h, we get 2 cubed minus 4 times 2 divided by 2 cubed minus 2 times 2 squared. And we're going to get 8 minus 8 over 8 minus 8. That's going to give us 0 over 0. So we have to, so again we get the indeterminate form 0 over 0, so we have to do something with the function. What we can do here is factor the numerator and the denominator. So we take the limit of factoring the common expression between the two terms in the numerator. It's h, so we get h times the quantity h squared minus 4. And the common factor in the denominator is h squared. So h squared factoring will get h minus 2. Okay, we evaluate the limit as h approaches 2. That is equal to, okay, the limit of h squared minus 4 over here is factorable, still factorable. So if we factor it out, we'll get h plus 2 times h minus 2 divided by the same expression, h squared times h minus 2. Now we divide h, so we take the limit as h approaches 2. We divide h by h squared, and then h minus 2 divided by itself, we get 1. So upon simplification, we'll just get the limit of h plus 2 over h over h. We'll write h here in the denominator. So evaluate the limit as h approaches 2. Okay, now substituting, we're evaluating the limit by substituting 2 again for h. We get 2 plus 2 over 2. Okay, and then we're gonna get 4 divided by 2, so the answer is 2. For the limit of h cubed minus 4h over h cubed minus 2h squared as h approaches 2. This is our final answer. Another example, take the limit of square root of x plus h minus square root of x over h as h approaches 0. So in this case, we substitute 0 for h and not for x, and we'll get square root of x plus 0 minus square root of x over, no, that's going to be 0. Okay, so that's going to be square root of x minus square root of x in the numerator. That's going to give us 0, and then 0 again in the denominator. So we get the indeterminate form again, 0 over 0. Therefore, we have to do something with the function to reevaluate the limit. Okay, so what can we do? So in this case, we can rationalize the numerator. When we say rationalize, we have to remove the radical signs in the numerator, and we can do that by multiplying both the numerator and the denominator by the conjugate of the numerator. So the conjugate is square root of x plus h plus square root of x. Okay, we have to multiply the denominator also by the same expression. So in this case, we're just multiplying the given function by 1. If we simplify this, this is just equal to 1. So we are not actually changing anything in the function. Okay, so multiplying square root of x plus h minus square root of x by its conjugate. So to find the conjugate, we simply change this sign to positive. Alright, so multiplying, so just to recall the formula for special products, the product of a minus b and a plus b, when simplified, is just a squared minus b squared. So this is our a, and this is our b. Okay, so it's a minus b times a plus b. So we'll get the limit of So squaring a, we get x plus h. Okay, this is a and this is b. Squaring a, we get x plus h, and then minus squaring b, we get square root of x squared, we get x over the product of the denominator, that's h times the quantity square root of x plus h plus square root of x. We evaluate the limit as h approaches 0. Okay, now we go up here. Okay, x minus h minus x, combining like terms, so we get x minus x 0. And now simplifying, we get limit of h over h times the quantity square root of x plus h plus square root of x as h approaches 0. Simplifying further, we divide h by itself. Alright, so now we have the limit of 1 over square root of x plus h plus square root of x as h approaches 0. Okay, now re-evaluating the limit by substituting 0 for h, we get 1 over square root of x plus 0 plus square root of x. We'll be getting 1 over the square root of x plus itself. And square root of x plus square root of x is 2 square root of x. So this is our answer. The limit of the given function.